Note page 234, half-life example 3. So our last half-life example in the notes. So let's read it. How much was present originally in a sample if chromium Cr51 if 0.75 milligrams remains after 168 days? And note, half-life of Cr51, chromium 51, is 28 days. So, if 0.75 milligrams remains, that means that this represents our final mass, not our starting mass. Remains after 168 days, so that represents our total time that has passed, and we are provided a half-life rate of 28 days. So now, remember, in our first line, that's always our starting point. So, no time has passed, 0 cycles have occurred, and what we need to actually figure out is what was the original mass. So, first thing we need to do in this type of problem, okay, so number 1, calculate the number of cycles. We want to figure out how many of these. So it's always your total time divided by the half-life rate. So 168 days divided by the 28 days per cycle. Then when you put this into your calculator, it means 6 cycles have occurred. So I'm just going to fill in all the way down to 6. So I'm going to have to add an additional line here. So I don't really need to fill in the individual times, but when I go from 0 cycles according to this problem all the way down to the 6th cycle, that means 168 days have passed. Okay? Now, when the 168 days pass, my 6th cycle has occurred, back up to the problem, it tells me my final mass is 0.75, and I'm just going to put the unit milligrams up here. This is the final mass. So what I need to do is I need to work my way backwards from the final mass to the original mass. So remember, in our normal direction, original mass to final, we cut in half. So that means when we work backwards, we have to double or multiply each one by 2. So the cycle before I had 0.75 means that I had 1.5 milligrams. Then the cycle 4 is double that, so that would mean there was 3.0 grams present. Cycle 3 has double the mass compared to cycle 4, so 6.0 milligrams. Cycle 2 has double the mass compared to cycle 3, so that would be 12.0 milligrams. Cycle 1 has double the mass compared to cycle 2, so 24.0 milligrams. Don't stop there. You got to get all the way back to 0 half-lives, when no half-lives are passed for the final answer. So when no half-lives have passed, that means I started off with 48.0 milligrams of original radioactive sample. And of course, you can go through and fill in the fractions or percentages to practice that. So when 0 half-life cycles have passed, it's always a fraction of 1 over 1, or that 100%. That never changes. At the end of the first cycle, half of the original remains. At the end of the second, it's cut in half again, so that's 1/4. The end of the third, it's cut in half again, so that's 1/8. At the end of the fourth, the mass is cut in half again, so 1/16. At the end of the fifth, the original, it's cut in half again, so it means 1 over 32, so 1/32. And at the end of the 6th cycle, it's cut in half again, so it's 1/64 of the original mass is still present. So I just want to reiterate that the cycle number, the half-life cycle number that's passed, it always matches up with the same fraction or percentage. That never changes.